Hello friends. In this session we will be discussing the parity of arithmetic operations. It's a very simple concept. Let us say I am looking at in adding an even number and even number. So even number plus even number. Obviously even plus even will be even. So even plus even is equal to even. Okay. Similarly, if I am looking at adding an odd number with another odd number, odd plus odd, let us say 3 plus 5 is 8, that would also be even. So odd plus odd is also even. On the other hand, even plus odd would be odd. Let us say now if I am adding 3 even numbers, the sum of 3 even numbers, that would also be even. The sum of 4 numbers, that would also be even. In general, we can say that the sum of any number of even numbers will always be even. So point 1. Sum of any number of even numbers is even. As far as the sum of any number of odd numbers is concerned, there are two possibilities now. In case I am adding an even number of odd numbers, that will be even. So if it is even, then it will be even. If the total number of odd numbers that we are looking at, that is odd, then it will be odd. So the sum of any number of even numbers is even, the sum of odd number of odd numbers is odd, the sum of an even number of odd numbers would be even. Same thing would be true for subtraction also. So whether it is addition or subtraction, as far as parity is concerned, there is no difference. So whether sum or difference, the parity would always remain the same. If you look at multiplication, in the case of multiplication, we can very simply say that in any multiplication, if even one of those numbers is even, then the product will be even. Alternately, the product of any numbers which are being multiplied, the product would be odd only if each of them is odd. If even one of them is even, then the product would be even. So the product of any number of terms is odd only if each of them is odd, else it is even. So now on the basis of this, let's understand this better and look at a couple of simple examples. Let us say I am adding the first 25. The sum of first 25 natural numbers. If I am adding the first 25 natural numbers, out of those 25 natural numbers, 13 will be odd and 12 will be even. Because there is whatever number of even numbers, their sum will be even. There are 13 odd numbers, the sum of these 13 odd numbers, that will be odd. Odd plus even is odd. So therefore the sum of first 25 odd number natural numbers, this would be odd. Number 2, first 25 odd numbers. The sum of first 25 odd numbers, it is an odd number of odd numbers, so that will again be odd. So the sum of first 25 odd numbers is odd. The sum of first 25 let us say even numbers, any number of even numbers added is always even, so this will be even. The sum of first 25 prime numbers, if I am looking at adding the first 25 prime numbers, out of these 25 prime numbers, 2 will be there, which is an even number. Besides 2, all other prime numbers, they would be odd. Overall 25, so there will be 24 odd numbers. 24 odd numbers is even, and there is a 2, so 2 is again an even number. Even plus even is even. So the sum of the first 25 prime numbers would be even. In general, we can say that the prime numbers will follow the same rules as odd numbers, because except for 2, all prime numbers are odd. However, whenever there is any deviation in the behavior of the prime numbers from the behavior of the odd numbers, the reason would be 2. So whenever there is any deviation in the behavior of prime numbers from that of odd numbers, the reason would be 2. So if the sum of an odd number of prime numbers is even, then that would be because of, that would mean that definitely there is a 2. Similarly, if the product of any number of prime numbers is even, then 2 is definitely one of them, else it would obviously be odd. So that's about the prime numbers, even numbers and odd numbers. Now let's take a couple of examples on this. Consider these 5 statements. We have to decide which of these statements are true given these additional cases A, B, C. In case A, X, Y, Z are even, case B, X, Y, Z are odd, and in case C, X, Y, Z are prime numbers. Now, so these are the 5 statements that are given to us. Now let us see which of these statements would be true, and depending upon each of these cases. The first one, X, Y, and Z, these are even. In case X, Y, and Z are even, it would be pretty obvious that whatever arithmetic operation I am performing, even plus even is even, even into even is even. So in every case they have to be even. So therefore in each of these cases it has to be even. So wherever it is odd, it would be false. Wherever it is even, it would be true. So the first one is pretty obvious. The second one, X, Y, and Z are odd numbers. If X, Y, and Z are odd numbers, X square Y will be odd, Y square Z will be odd, Z square X will be odd. So odd plus odd plus odd is odd, odd multiplied by X, Y, Z will also be odd. So odd into odd is odd. So this statement is true. The second one, X plus Y, the sum of 2 odd numbers is even. So this will be even, this will be even, this will be even. So this statement is also true. The third one, X minus Y plus Z. So now whatever may be the parity, whether it is addition or subtraction, 3 numbers being added, it will 3 odd numbers being added, it will be odd. So this is odd, this is odd, this is odd. The product will also be odd. So this is also true. The fourth one, the product of any 2 numbers which are odd, it will be odd, odd, odd. Together this becomes odd. Odd 2x will be even, even plus odd is odd, odd square is odd. So overall odd into odd. So this statement will also be true. And finally 2x is even, 3y is odd, 4z is even, even plus even is even plus odd is odd. So this becomes odd, multiplied by x, y, z is odd, odd plus 6 is odd, odd into odd is odd. So overall this statement is false. So except for E, all the other 4 statements, they will be true. The third one, wherein X, Y, and Z, they are prime numbers, this would be slightly more complicated. Because if I am looking at X, Y, Z being prime numbers, now there may be a 2, there may not be a 2. In case there is no 2, then X, Y, and Z, they become normal odd numbers. And if X, Y, Z become normal odd numbers, then they will follow the same procedure as for odd numbers. So in that case we know what will happen, except for this last one, all the 4 statements would be true. However, if I look at the possibility of a 2 being there, then this becomes slightly different. Let us assume that there is a 2. If there is a 2, then X, Y, Z will be even, even multiplied by whatever, this will be even. So this statement becomes false. The second one, X plus Y, Y plus Z into Z plus X, at least one of these 3, it will be even, because one of the terms is odd. If even, 2 of the terms are odd. If 2 of the terms are odd, odd plus odd will be even, even multiplied by anything will be even. So therefore this statement is necessarily true. The third one, X plus Y plus Z, if one of them is even, 2 of them are odd, odd plus even will be even. So even, even, this will be even. So this statement becomes false. Fourth one, xy plus yz plus zx, two of these 3 terms will be even, the third one will be odd. So even plus odd is odd. So overall this quantity becomes odd. Over here 2x plus y, now 2x is definitely even, depends on y. If y is odd, then it will be odd. If y is even, then it will be even. Now 2 could have been x, y or z, so therefore y can be even also, which means that together this product, it may be even, it may be odd. So I cannot say for sure that this statement is true. The last one we had already seen that for odd numbers it is not true. So therefore if x, y and z are prime, then only one of these 5 statements would be necessarily true.